Okay, good morning. So let's first I just want to solve that problem. Might be some of you are interested in higher level mathematics. So let me solve that problem for you. Uh, so do you remember we are supposed to show this uh, 2 to the power of 3 to the power of x plus 1? If you don't mind, let me respect the large, so how large I write them. So this one is bigger, and then this one is a little bit smaller, and this one is also smaller. You multiply this by 2 to the power of 3 to the power of x. Yes? And then you are supposed to show that this becomes 16 to the power of 3 to the power of x. Yes, so I haven't asked you to find the value of x. We can also solve some of those questions that you are supposed to find x today. Those are called equations, yes? So let me also teach you these words: equations, equation, an equation, or an identity. Okay, so what do I mean by these words in mathematics? When I give you an equation, I give you an expression like this. You have equality in an equation. You have a letter there which is called an unknown, and you're supposed to find it. Okay? But here, what is the meaning of an identity? An identity looks very similar. You have equality, you have a variable or some variables involved. But identity means that always the left-hand side is equal to the right-hand side. Yes, for example, 2 times x plus 1 equals to, if I multiply 2 in, it becomes 2x plus 2. This is equality. It contains a letter x, but I will not call it an equation. I will call it an identity. What does it mean? It means that regardless of your choice for x, the left-hand side becomes equal to the right-hand side. And if I want to ask a question regarding an identity, I will not ask solve an identity. I will ask you show that this identity is true, or prove this identity. In contrary, if I have an equation, this is now an equation, for example. This is an equation. Why? Because it depends to my choice of x. This is not guaranteed that the left-hand side is always equal to the right-hand side. If I choose 0, the left-hand side becomes 1, the right-hand side 3, doesn't match. But if I choose 1, the left-hand side becomes 3, the right-hand side is also 3. So it's sometimes true, sometimes false. This is an equation, identity, an equation. Here I should ask show the identity is true. Here I can ask solve the equation. Okay, so what I'm saying is that I want you to understand the difference between this word in mathematics and that word. They look very similar. They have the same structure. They have equality. They have unknown. But one of them is true for all choices of the unknown. One of them is true for some possible choices of unknown. And you're supposed to find them. When I ask you to solve an equation, I mean find all possible values for x so that this holds. So here I am asking you to show this identity. I am not asking you to find x. Okay? So in this case, it means that I have to prove or show with a convincing argument that the left-hand side, no matter what I choose for x, is always equal to the right-hand side. Yes? Okay, this is the lesson that we learned. Okay, so let me just try to make a good understanding of this question. If I ask you, is this a power? You will tell me, yes, this is a power. The base is what? 2. The exponent is 3 to the x plus 1. Yes? If I ask you, is this also a power? Your answer possibly is again yes. But if I ask you what the base is 2, but the exponent is 3 to the x. And then I am multiplying them. So I am multiplying two powers with the same base. And there is a rule for it. We learned that 2 sessions back. We also practiced yesterday. So if you have 2 powers with the same base and you want to multiply it, you need to remind yourself of one very famous rule. Number 1. What was that number 1? A to some power m multiplied by a to some power n is equal to a to the power of n plus n. Yes? So I am multiplying 2 powers with the same bases and of course with different exponents. But I mean that you need to interpret it in that way. So these formulas are not just soulless mathematical formulas. They are talking to you what to do. So you need to be able to read it in Swedish, English, or any language that you want, but you should be able to read it, decipher the formula, okay, in the normal language. Okay, so what happens here, I would say that I am supposed to write the common base. So I would, by the way, this is the standard way of writing. The left-hand side, for short, is equal to this times that. I would write the same base too, but what I'm supposed to do, I am supposed to add the exponents. And if you don't mind, let me make it a little bit bigger, make it clear. And then the exponent of the first one is this. The exponent of the second one is this. Yes? Everyone understands what's going on? Okay. So I am using this rule. And then I was able to write it this. Does this equality depends on my choice of x? No. For every choice of x, I can do something like that. And then you want to reach to this one. Some problems happens, yes? Because first of all, on the right-hand side, I want somehow to make the base from 2 to 16. So I am talking about this. I can solve the problem and you will understand. I am trying to talk around it so that you learn how to think. Even if you learn how to think, still mathematics is hard, let alone you don't know how to think. Okay? So how can I do that? Here, I would say that, okay, there are some differences here. First, I see the difference between these 2 and 16. I don't see any way out of it. How can I change 2 to 16? Still, I don't know. Okay? But there is also another difference here. The exponent here is 3 to the x, but the exponent here is a little bit more complicated. So what I do, for example, I can go to a scratch paper here and try to do something for it. Okay? And then I want you to ask your opinion. You see, I am completely sure you should be able to solve this one or simplify it. If you have, because I'm sure we have practiced this concept in a different problem. This is some skill that you need to learn. To learn that skill that you learned in some problem, I will show you later, is also useful here. Now, can you tell me how can I combine these two? Can I use the first rule again? Yes or no? Yes or no? Yes or no? Don't make me disappointed. No. This is product. This is sum. Yeah, math. So this is not correct. So you're not allowed to use any rules. We don't have any specific rules for adding 2 powers with the same bases. Yes? Okay. Unless you remember something from previous lessons. And this is why I'm saying you try to improve, pay attention, send to your memory. You have to be active in learning. And then, of course, then mathematics becomes very, very smooth, especially at the high school level. Okay, so do you know, okay, do you have any suggestions for me if I want to write something? Yes? Exactly, thank you. Splitting rule, okay? So that is the same rule, but I can only apply it here. Yes, so I would write 3 times 3 to the power of x plus 3 to the power of x. By the way, I don't need to go to a scratch paper because I realize what to do probably. I will continue here in the main line, yes? So I would write 2. I learned that instead of this guy, I can write 3 times 3 to the power of x. And then I have another 3 to the power of x. But hopefully everyone agrees that for this guy, we can write a better name. What that name is? I don't know why you have this problem, because if I ask you to what is this, I'm sure that all of you will answer. What is the answer to this? So why don't you answer this one? This is something you need to teach yourself. Yes, I'm just trying to draw your attention to it. I cannot drill your brain to make it there. So this, I'm sure that you can solve this, and you did. You just immediately told me 4a. But when it comes here, you have a little bit problem. So this is something in mathematics. This is a number, and that is the same number. You have 3 of those numbers, and you are adding another of that number to that sum. So what is the answer? So you have 3 of something plus the same thing. So how many of that things you have? No, you have 3 of them, and you have another one. 4. You have 4 of them. So that's the same story. So this becomes 4 times 3 to the x. Yes? So this is the way that I think. When I reach here, I become a little bit happy, because I see that I am making progress. You see, at least this 3 to the x, which I need, appears here. And then the problem is that I have 2, and then fortunately I have a 4. And if you have done your homework before, so you know that there is a connection, okay? And now I want to ask, can I write this in this form? If yes, why? According to which rule? Can I write this? Why? Can you tell me the rule? What was the rule? A to the power of m, and then to the power of n. It is a to the power of m times n. Okay? But usually students are better for going in this direction. They have a little bit problem if they don't pay attention to go in the other direction. And I told you that usually hard problems, you need to go from this side to that side. So we are doing it here, yes? Is that clear? But nobody usually writes 2 to the 4 because it has a better name. What the name is? 16, and then we are done, aren't we? So this is 16, and then on top I have 3, and then I have to the x. You shouldn't write. So I started from the left-hand side. I calculated everything without even knowing what x is. I don't care about the value of x. Whatever I have done here can be done for any choice of x. And then I reached to the right-hand side. So I would say it is equal to the right-hand side. So if you see, if you do not look here, what happened? I was able to show that whatever is on the left-hand side is equal to whatever is on the right-hand side. So that is an identity. Regardless of the choice of x, this equality holds, and I was able to show it. I didn't ask for solving it. On the other hand, for example, I can give you this 4 to the power of 2x. This is equal to 16. So here it is clear it is not an identity. Yes, because for example, if I choose x to be 0, then 2 times 0 is 0, 4 to power 0 is 1, 1 is not equal to 16, yes? So then for this I can ask solve the equation. What do I mean by solve? I mean find all possible correct answers for your variable. Here you have to find x so that this holds. There is no guarantee this is correct. You have to make it right. And that means that, okay, this is very simple. For example, here I have 4 to the x, and then on the right hand side I can write 4 to the power of 2, yes? Why did I do that? Because I wanted to make the bases the same so that I can compare the exponents. So the 4 to some power that I don't know is supposed to be equal to 4 to power 2. This cannot happen unless the exponents match. So this means that from here you can conclude that 2x is 2. Then from here you can conclude that x is equal to 1. And that is solve. So in this one, if you want to write the final answer, you need to write this. Is that clear? Okay, so that is something, I think it's a good question. I want to give you another one. Let us see. It's a little bit challenging. But let me write it down here for you. By the way, let me see if this is, yeah, the voice is being recorded. Okay, so let us go back here. Uh, so I think I chose this from an Indian book. I really like them. I think the hardest questions that I have ever seen are from Indian books, and I'm very actually fond of them. So I just want to give you some exercise here. So can you simplify this expression? By the way, this is for 7th grade in grundskolan. Okay, so I mean they are actually studying a little bit advanced level. Okay, so let me just write it down here for you. A to the power of, I want you to simplify this. I want to see how many of you can do that. Let me make it bigger. So that I can see it from that distance. Oh, sorry. Okay, so a to power 16 multiplied by big pair of brackets, and then you have a to the 2, b to the power of, no, b just b, and then you have a to the power of 3, b to the power of minus 4, and then the whole thing to the power of minus 3, and then you divide this by a b to the power of minus 1, and then a to the power of minus 3, b to the power of 2, the whole expression to power 5, and then closed. Okay, I want to give time to you, because I think that if someone can solve that problem, you are really on the safe side, that you know everything about power so far. Okay, it takes a little bit of time. By the way, they have only probably 90 seconds or so to be able to answer that, but forget about those. So you should be able to answer, because this is multiple choice question. I can also give you the choices, but you don't need to do that. Whenever you found your answer, I will register it under your name there, and then we'll see which one is correct. So let me see. Can you read everything? Yes. Be careful about the minus signs and everything there. So let me make it more transparent. This is also minus. Yes. So my goal is that you should be able to solve it. I don't expect that you solve it in an optimal way, but try to just do it and give me the final answer. Yes. Yes, please. Yes, yes, you can come, but you will be in the camera. Okay, that's good. Yeah.
I don't understand what happened to the x right there.
Here?
Yeah. For the 3x.
This one?
Uh,
Here, I have written here. So 3 to the power of x plus 1. I just copied and pasted this part. And instead of this thing circled, I have written this. Do you agree? Because this is 3 to power 1.
yes.
3 to power 1 times 3 to power x becomes 3 to power 1 plus x.
1 plus x, yes.
But here I just decomposed that. And then I wrote it. So I wrote this one here. Then I asked this question. I have 3 of these numbers
Yes.
plus another of the same number. So it means I have 4 of them.
4 of them.
Yes.
That's what you did.
Yeah.
Okay,
Yeah.
now I understand. Thank you
Yeah.
so
You're
much.
welcome. You are asking about the number. Which one? So let me read. 16, 2, 3, minus 4, minus 3, minus 1, 5, minus 3, 2. You're welcome. let's come back. So let me write. This is minus 4. Sorry if my handwriting is not readable here. Uh, what is your answer?
1 over AB powered by.
No, I don't think it's correct.
It's not.
No. Yes?
I don't know if this is the right form to say it, but a to the
Let me try to solve this for you. I will explain it in full details, but I mean, you really don't need to spend so much time. If you are quick, you can do a lot of things in your head. But let us try to solve this problem case by case, okay? So only consider this one. By the way, this is some skill that you need to learn. If you have some hard problem, you don't need to solve all part of it. Even if you solve partially, you get partial points in the exam, okay? So if, for example, there are 3 points for this question, if you can simplify just one part, you at least get 1 point. So even if you cannot solve the whole problem, you still can get some points by solving parts of the problem. So let me just ask you, what do you think about this? You know, a to the power of 2 times b divided by a to the power of 3, b minus 4, okay? Only let us consider, so let me just write everything, to the power of minus 3. If I want to solve that problem myself, okay, what I do, I immediately can write it as b to the 5 divided by a to power minus 3. How many of you agree with that one? Yes?
Wait, was that a 4 or a 9?
I told you that it's a 4.
Why
Okay,
isn't it
because
negative 1? Isn't it 2 minus 3?
No, I just want to describe 2b 3 minus 4 minus 3, yes? So, can you describe how did I do it so quickly to be this? Can you describe, is it true or false? What I have written is true or false?
Isn't the A1, bro?
So let me describe everything for you. So a to the power of 2.
Oh, okay.
So this expression can be written as a to the 2 divided by a to the 3 times b divided by b to the power of minus 4. Do you agree? I didn't go through these steps because I have practiced a lot, so I can do this quickly. But can you imagine that I can write this in this form, yes or no? Yes? Okay, and then you have the rule. I have a to power 2, and then I have, so by the way, I can even, so anyway, if I want to solve it, you can write a to the power of 2 minus 3, and then you can write b to the power of 1 minus 4, according to the rules that we studied yesterday. Yes? So this becomes a to power minus 1, this becomes b to power 5. Do you agree? So if you don't mind, let me just write it like that. It is easy, even better. So I write it as a to power minus 1, b to power 5, and then I have to power minus 2. Yes or no? Yes?
I'm sorry if I say late. Can I say my new answer?
Yes?
1 over 8.
Yes, and I think that's correct because Tasnim also got 1 over a.
was it correct?
No, I don't know. I don't know. I have to calculate. But I think that cannot be a coincidence. And that's very good if you can solve it. Thank you. So, first of all, do you agree that I can write this like this? You should be able to do it quick and fast. Is that understandable? Now, I want to use another rule for this one. It's a product. You remember we studied yesterday. A to power m times b to power m is equal to a times b to power m. We studied this yesterday. So it means that sometimes I need to go in this direction, sometimes I need to go in this direction. This is one of those problems that I want to go in the opposite direction. So what I do, I would write the number here to the power of minus 3 and the number here to the power of minus 3. I am using this rule in the opposite direction. Do you understand that this is this rule? Yes or no? This tells you that if you have a product, you need to improve this skill to read this one. This from left to right, this tells you that if you have two powers with the same exponent, you multiply the bases and put the exponent. This is the way that you read it from left to right. How do you read it from right to left? Can anyone read it for me? If you want to read the same formula from right to left, how do you read it? Yes?
A to B to the power.
No, read it. You're just reading the formula. What does it tell in English? So you don't listen to me. When I want to read it from left to right, how do I read it? To multiply two powers with the same exponent, multiply the bases and put the same exponent. This is one way of reading from left to right. Reading it from right to left, how do you read it? If you have a product supposed to be raised to some power, raise each one of them to the same power and multiply them. So this is one way of reading it from right to left. This is important. These are actually codes. By looking at them, you should be able to read this sentence in English or Swedish or your language, yes? So here, what is this one? This is a product. I have a product, I want to raise it to some power. So this is from right to left of this rule. So it means that raise the first one to that power, raise the second one to that power, and then multiply. Yes or no? No. But now there is another rule we studied yesterday. I have a power, another power on top of that. So what was the rule? Just to multiply these exponents. So this becomes how much in your head? Minus 1 times minus 3 is positive 3. And 5 times minus 3? Minus 15. So it's b minus 15. Okay? So you are done with this part, you see? Okay, so let us do the other one a little bit more quicker, because that's more or less the same thing, and now you have enough experience to do it. So the second one, let me be patient and write it here for you. This one divided by a to the power of minus 3, b to the power of 2, and the whole thing to the power of 5. Okay, so can you just see that what can I write here? A and A with different exponents. I am dividing them, so I write one of them. And what is the exponent which is not written? 1 minus the exponent here, which is 4. So this becomes A to the 4. And then B to the power of minus 1 divided by B to the power of 2. So I have to write this exponent minus this exponent, which is minus 3. So it becomes B minus 3. And then I have another power of 5 up there. So then it means again the same story. A4 to the 5 multiplied by B minus 3 to the 5. Then it becomes A to 20, B minus 50. Yes? Yep. Okay. Now we have to divide these two expressions. The expression I got before was A to the power of 3, B to the power of minus 15. I have to divide. I told you that in high school, instead of using this division, it's better to put this line. So I'm just dividing by this expression. Okay, can you simplify it for me? These terms are completely gone. And then what is left for me? A to the power of? Minus 17, thank you. It's minus 17.
So then it's...
So your answers, both of you are correct, thank you. Because now there, instead of this big pair of brackets, I can just put a to the power of minus 17. I hope that you enjoy the process. That's an art, by the way. So instead of working with that very complicated expression, I just want to work with this one. So then you have a to power 16 multiplied by a to power minus 17. Yes? And then what happens? It becomes a to power 16 plus minus 17 is minus 1. So that is the correct answer. But if you look at the options, this is not written in this form. They have written it in this disguised form. But a to the power of minus 1 is correct. 1 over a is another name for this one, which is also correct. But if you see the options, you see this one, not that one. Thank you very much, you two. Thank you. Yes. Because you made a mistake because of that number, yes? No worries. So it means that your understanding is very good. Thank you. Okay. Now, let me just show you some. Um, uh, so let me just. Okay, so you see, I want you to solve this one. I hope that you are not mixing things. So let me just. Oops. Sorry.
What eighth grade is this? We had this in eighth grade. Seventh. If they had, if I had this in seventh grade, I would be grade seven. Now you're very smart right now.
Okay, so I want you to just think about. This is actually not this lesson. This is not. This has nothing to do with powers. So I want you to be able to calculate this for me, but try to do it as fast as possible without calculating. Let us see. Can you also have this competition with them? So here, I want you to calculate this expression, yes, and then you are supposed to find one of these answers, okay? It has nothing to do with power. It is basic arithmetics. Do you remember I started with basic arithmetics? So in principle, you need to be able to solve it, okay? So I want to wait for you to see how many of you can solve this. No calculator is allowed. And then try to do it as fast, as efficient as possible, okay? Number 3. Yes. Okay, so let me try to explain how to solve this problem. Let me change. I have written the question, the numerator and the denominator separately. So this is the numerator, yes? So if you want to solve this, I would recommend you first of all get rid of this mixed fraction here. So which is what? 8 over 7. There is nothing in particular I can do about this for the time being. Just copy and paste it. But the best way to calculate this, I have already talked about this for you. I don't know how many of you remember. Of course, you can take the common denominators and things like that, but rescaling the best and optimized way of doing it. So if I want to solve this in my head, I multiply everything by 25. Because please listen to me so that you know these tricks. You can multiply a fraction. This is a fraction. In numerator, I have a fraction. In the denominator, I have this. I multiply everything by 25 because 25 is the smallest number that led me to get rid of all these smaller fractions. So if I multiply it by 25, can you tell me in your head, if I multiply this by 25, what will happen?
Multiply by 25 or multiply to 25?
No, everything. The numerator by 25, everything by 25. I am rescaling it. Yes? It doesn't change the answer. But it is more efficient. And I don't even... What is the answer to this immediately? 1 second.
50 over 125.
What?
50 over 125.
No, that's what I'm saying. That's wrong. Be careful.
It's 50 over 5.
First of all, 25 should be only multiplied by 2. So it is 50 over 5. Okay, but don't get used to it. Even though 50 over 5 was so simple, but don't do it. Try to simplify this in your head. 5 and then multiply it 10. So the numerator becomes 10. Yes? And the denominator, you multiply this by 25, keep it in your head. 25. Multiply this by 25, which is? What is this? Multiply this by 25.
You get
1. 25 multiplied by 1 over 25. This one and that one are gone, so it's 1. So it is 25 minus 1, 24. But 10 over 24 is not a good name. We have a better name. What is that? 5 over 12, because I can divide by 2. And this is so you have to learn simplifications, okay? So this is your numerator. Yes.
That's 1 minus. Oh, you also multiply.
You have to. You have to.
So you multiply the 1 by 25, but also the 1
Yes,
by 25.
yes. Because you have to multiply the whole package by 25. Hello, are you from our lesson? So please be up. Yes. Are you from this class? Yes. So why are not sitting? Yes. Okay. And then what we were supposed to do, either you can continue with this one, which I don't recommend. I will keep it for the time being. I go back here. Okay, now I told you the trick. Can you do it in your head? If you want to do this part, what do you do?
Multiply by 25.
Isn't there a minus 1 there?
Where?
Yeah, but the 25 is multiplied.
So I told you that. Let me tell you.
They're not there at the start.
Here, you multiply everything by 25.
Isn't it 1
No, but
minus
this
1
becomes, I wrote 8 over 7.
Yeah, but there it says 1 minus 1 over 7.
That means you flipped it.
No, this is different. This is the denominator, this is the
Is that
numerator.
the denominator? Okay.
Yeah. So now I go back here. So can you do this part in your head? This part. Yes?
Is it 1 minus 10 over 10?
No, multiply by what? If you want to do it quickly, just you don't listen to me. I told you it is better to rescale. Let me tell you. If you want to do it normal way that you have learned, what do you do? If you do it normal way, you just copy and paste the numerator. Instead of 1, you write 5 over 5. And then minus 2 over 5. And then you write 2 over 5. And then you write 3 over 5. And then you write 2 over 5 divided by 3 over 5. And then you write 2 over 5 multiplied by 5 over 3. And then this is cancelled, you get 2/3. This is the normal way. By the way, even if you do it quick, it doesn't take that much time. Okay? But it's much easier if you learn this trick. If you have a fraction with other fractions involved, instead of doing it the normal way, the optimized way to do it is to get rid of these fractions by multiplying by an appropriate number, the smallest appropriate number. What is the smallest appropriate number for the whole fraction? Is 5. So if I want to do it in my head, I multiply it by 5. I remember it is 2. I multiply this by 5, which is 5. I multiply this by 5, which is 2. It is 2/3. Is that clear? So it is as fast as this. So this is 2/3. And I have 1/3 added, which is 1. And 1 multiplied by that is just 1 over 7. So the answer is just 1 minus 1 over 7, which is 6 over 7. Agree? So that is 6 over 7. And now I have to put it back here. And then you have to simplify that. Again, I ask you to do the same trick. What is the best number to multiply to rescale here? A number so that it is the smallest possible number, but it lets you to get rid of all these fractions. So that is the least common multiple of 3, 7, and 12. Can you guess it? 7, 3, 84. Yes, exactly. So you multiply by 84, but if you multiply it by 84, what happens? I don't want you to multiply it, because even it is hard for me to multiply this by 80. What I do, I simplify this in my head, which is 12 times. Yes? So instead of multiplying 84 by 8, which is hard, I just need to multiply 12 by 8, which is reasonable, 96, yes? Yes, 12 times 80 becomes 96. And then 84 again, 84 multiplied by 2/3. If you simplify this with that, how much do you know? If you have 84 crowns, you divide it into 3 pieces, equal pieces. How much do you have? 28. Yes? So you have 28. And 28 multiplied by 2, 56. And then you multiply 84 there. 84 multiplied by 5 over 12. How much? 7 times 5? 35. You multiply this by 84, you have to multiply this by 84. So 84 multiplied by 6 over 7. What's the answer again? It's 12. 6 times 12 is 72. 6 times 12, 72. Yes? And now look, 96 minus 56 is 40. 40 plus 35 is 75. So the answer is 75 over 72. And then you simplify by 3. It becomes 25 over 24. But 25 over 24, if it is not in the solution, it is not in the options, but this one was, yes? And that's the answer. So I just want you to learn, if you have enough time, you have to be able to do it. But my advice to you is try to do it in an optimized way, as fast as you can. Yes, that's up to you. Okay. Something that I want you to know is to be able to put this in GeoGebra as well. Okay, so let me just open GeoGebra. So I go to cast view, and then I will, because this is something that you need to train yourself. Let us take this view out, we don't need it, and try to actually type it to see what happens. So the only thing that I don't know, we don't have any way, I think, to put mixed fractions in GeoGebra. If you found it, please let me know as well. So I do that part in my head. It is 8 over 7. So I will start typing 8 over 7. And then I go here. I have minus 2/3, minus 2 over 3. And then I go here. I have 2 over 5. Sorry, I have plus. And I have... Oops. Yeah, so I have plus, and then I have 2 over 5. And then I go here, you see, you put another division, it automatically goes to the denominator. So I have 1 minus 1 over 25. And then the whole expression, so should be, oops. Yeah, I have to anticipate that there, okay, that's good. So the whole expression should be divided by that expression again, which is 1 minus 1 over 7, and then open brackets here, and then I have to write 1/3, and then plus, and then I have 2 over 5, and then I divide, and then I get 1 minus, so I messed up, yes? So I have to divide 2 over 5 and then go. So this is what I'm saying, that you need to learn how to type efficiently. Minus 2 over 5. So hopefully I have done everything right, and then let us see what the answer is. So the answer is 25 over 24. So this is some skill that I want you to learn. You see, I also messed up some typing. So you need to improve your skills, otherwise it will be time consuming in the exam session. Okay? Another question here that I see this in this Indian book, I don't expect you to be able to solve it, but I would take this one, you will see it in the video, and put it in GeoGebra. I want you to understand how you can put this question in GeoGebra. It will teach you a lot, because this is quite advanced problem, by the way. So I don't know how they managed to learn these things before coming to high school, but we can solve this also later if you want to in an analytic way. But what I expect you is to be able to put this in GeoGebra using that sum rule. Do you remember I told? So you need to discover the pattern. So can you guess what number is coming next? If you can guess, it means that you were able to discover the pattern. And when you have the pattern, and then do you remember we had some sum rule in GeoGebra. So you should be able to put this there, okay?
Is it 1,296?
What part? This one?
Yeah.
3 over 4, 5 over 36, 7 over...
It is
Yeah. The answers are these four. Yes, these answers. So this you should get one of these answers at the end. Okay. Yes, I don't know. The numbers are clear. They have been typed here. So I think everything is readable.
This next number, 9 divided by 1,000.
Okay, man.
Oh,
1,000? You mean 10,000?
no,
Because
1,000.
look, that's 8,000. How would you get 1,000 after 8,000?
No, not after 8,000. I'm talking about.
So can you tell me what is the number exactly? So can you tell me what the pattern is?
Is
So the number that you said 9 is correct. What is the denominator?
1,268.
1268.
No, 96.
How did you get it? I think it's correct.
It's the difference between the first one and the second one is 9, and then the difference between the second one and the third one is 4. And I was like, then if they continue that pattern.
Okay, so let me put this for challenge. If you are interested, please think about this problem on your weekend. Yes. Yes, it's a good thing to make you busy for the weekend. So I think it's good. But I don't want you, if you want, of course, you can solve it analytically without GeoGebra. But at this level, I don't expect you to do that. I expect you to be able to put this formula in GeoGebra using the sum syntax.
Baba, I need to go to my dentist appointment.
Yes, the lesson is more or less finished.
Okay.
Yes.
Yeah, I have one more. It's for the upper jaw.
Do you want to see the question?
How bad did you mess up your teeth?
Okay.
I have to go 3 times so much.
So let me make it a little bit bigger for you. So this is the question. So if you are taking notes, make sure that you are not messing up the numbers, because otherwise you are working for nothing.